Weather forecasting. In this lesson, we're going to learn about the little details that we need to know in order to forecast the weather. So here is a recent weather map of our country, and we will be learning about these L's and these H's and all these faint colored lines, and you guys probably already know what most of this stuff is, and these little symbols. We're going to learn about all these map symbols so we can then predict and forecast the weather. We're going to start with what was an H on the map. So an H is a high pressure area, and we get a high pressure area when cool air sinks, okay? And this will give us sunny skies. So when we have high pressure areas, usually that means that we're getting sunny skies. And you see here in this picture, we have the air coming down, and the winds are also tending to move clockwise around this high pressure area. Now, low pressure area had an L on the map, and you get a low pressure area when warm air rises and is cooled, and we know what happens when air rises and cools. It condenses, forms clouds, which is what gives us our precipitation and stormy weather. And completely different from a high pressure area, our winds are moving counterclockwise around the low pressure. So you see it's completely opposite from a high pressure. So here's a diagram comparing a high pressure area versus a low pressure area. Again, a high pressure area, we're going to have that cold air sinking, and we're going to have calm, clear weather. High pressure areas are also referred to as anticyclones. All right, versus a low pressure area where we have the warm air rising, which is going to give us clouds and ultimately then precipitation, stormy weather, also referred to as a cyclone. And here is a video clip actually of a weatherman explaining the differences of a high pressure and low pressure system.
Great question. So we're talking high pressure and low pressure. She's saying, why is high pressure associated with clear skies and light winds, and low pressure associated with storms and rain? Well, we're going to put it together this way. You have to look at weather as three-dimensional. That's the key here. That was one of the most difficult things when I went to college, when they started talking about the weather in 3 dimensions. I was so used to just staring at weather maps that I'd see in the newspaper here down at the ground. But everything at the ground is occurring by what's happening aloft here. So let's look at the jet stream. This is the jet stream here. This is high and low pressure here. Now you have to understand the water cycle too. Water cycle is as air rises, it will cool and then condense, because it encounters lower pressure. So the higher air rises, the pressure goes from high pressure to low pressure. You get less pressure, less temperature, it cools, condenses, makes clouds. So wherever there's rising air, we get precipitation. This is what's happening in the jet stream aloft. Here we'll have a convergence zone aloft here. That's when the jet stream winds are coming together. So as you push the air together, it has nowhere else to go. It can't go up, so it has to go down. So what happens is we have sinking air, and the air sinks, and it sinks clockwise. So it subsides, as we call it, subsides. As it's sinking, it warms because it encounters the higher pressure near the ground, and that sinking air also causes a big bubble of high pressure to form here. So sinking air near the high pressure warms and dries, and so you don't have any cloud cover out. We had that pretty much during the day today. As the jet stream is going along, it'll encounter an area where it diverges aloft, and so it separates the air here. We can't have a void. We can't make a vacuum with no air, so something has to replace the air right here, and so air comes up from the ground. So what happens is high pressure now has been over here, so that wind comes out of high pressure, it goes into low pressure counterclockwise, it gets to the middle with nowhere else to go, and it rises to fill this void right here. And so near low pressure we have rising air, and rising air will then cool and condense and make clouds and precipitation. So you basically have rising air causing clouds and rain, while sinking air is generally dry as it warms up. And if you look at high pressure, low pressure on the ground at the surface here, you also have wind that forms between the two. And as I mentioned to the kids, if I take a room and we fill it up with air and we seal it off and we pump a bunch of air pressure inside the room, then we open the door, the air will rush from high pressure to low pressure outside the door, and because the earth is spinning, it goes around clockwise like this. And so we added a little bit extra here, but generally stormy, not stormy. That's what you got to take away from that, Don.
Right, and I also like that he pointed out that wind and air will always move from a high pressure area to a low pressure area. When we discussed weather instruments, we talk about air pressure. being measured by what's called a barometer. So here's that root word. Here we go, B-A-R, bar. So an isobar is a line that connects areas of equal air pressure. So it's kind of hard to see, but all these little brown lines, those are our isobars. They're connecting our areas of equal pressure. So each line symbolizes one pressure measurement. And this looks like it's in millibars here. Another thing to note is the closer that the isobars are, the higher the wind speed. This map isn't as colorful as the last one, but it shows the isobars much, much better. And this should look like another kind of map that we've encountered earlier. Yeah, lines, yeah, like a topo map, right? And the top of this being like the top of the peak. And when the lines are close together, it means it's steep. So instead of steep like height with isobars, we're talking steep like a steep gradient, meaning that the pressure is changing really rapidly, which is going to cause us to have really, really high wind speeds. So over here in what looks like, southern Canada and Wisconsin, we're going to have really high wind speeds up in this area, as opposed to like Texas, so their winds are not going to be as strong there. You can also add one more layer to this. Oh, look, I see a little L in here. That means that there's probably some storm and precipitation going on there, and a little H over here, meaning that they've got some clear skies. Our next piece to the weather forecasting puzzle is our fronts and air masses. So fronts are the boundaries separating different air masses. So an air mass is what causes a front. It's a body of air whose temperature and moisture are similar. All right, and there are 4 different air masses that affect the United States. Each of these air masses is named according to its moisture content and to its temperature. So if it forms over land, then it's considered continental, and it will be dry or lacking in moisture. If it forms over the water, then it's referred to as maritime, and it will be moist. Okay, the second part of the word tells you its temperature. So polar, we think cold. Tropics, we think warm or hot. Okay, so continental polar is cold and dry. Continental tropical, continental, dry, tropics, hot. Maritime, moist, polar, cold. Maritime, moist, tropical, warm. Here is a picture of how the air masses and where they originate from in the typical paths that they go in. So our maritime over our ocean, polar from the colder parts of our ocean usually goes this way. All right, maritime, ocean, T, tropical, warm, look, comes from the warmer locations. And you can see that they can affect the United States in more than one location. Continental polar, coming from the colder regions, forming over land. All right, and then here is, we didn't discuss it, but continental Arctic. So same type of deal. Continental, dry, Arctic, cold. And then you notice that only in the summertime are we affected by this continental tropical or dry, warm air mass. Here's a map, and to emphasize, these are the fronts that we're going to be talking about and learning about, some of which you may already know. The first front is a warm front. So a warm front is where warm air replaces cooler air. These are usually slow moving and cause long periods of steady rain. And as you can see on here, this is their symbol. Kind of reminds me of a teddy bear, which is like a warm fuzzy to me. All right, so make sure you draw that symbol in your notes. And it is red. We think warm red. Here's a picture diagramming a warm front. So you see here we have warm air coming in, and it's replacing this cool air. But since warm air rises, it's going to cool and condense and provide us with some precipitation. A cold front, which is where cold air replaces warm air. These are usually short-lived and will bring us lots of precipitation and thunderstorms. Okay, and its symbol reminds me of like icicles. So maybe think like that is cold, so little blue triangles. So cold is blue, and so are icicles. Make sure you draw that symbol in your notes. So here's a picture. We have our cold air coming in, and it's going to replace this warm air over here, cause it to rise rapidly, condense, and give us thunderstorms and precipitation. A stationary front. So stationary means to stay and not to move. So these fronts often do not move and will provide us with persistent clouds or rain. And as you can see over here, the symbol is a combination of the warm and cold front. And it looks like they're pushing in opposite directions, causing the front to stay in the same location. So make sure you draw this front in your notes. Here's a picture diagramming a stationary front. So we have our cold air and our warm air pushing on each other in the same direction, causing these clouds, and it just kind of stays where it's at because they're pushing on each other, not going anywhere. The last type of front that we'll talk about is called an occluded front. And an occluded front is when a warm air mass is caught between two colder air masses and is pushed upwards. This will also give us thunderstorms and is found close to a low pressure center. And its symbol is the warm and the cold symbols going all in the same direction. So here we can see an occluded front from two different vantage points. Okay, so first things first, we have, like I said, our low pressure area. All right, our winds are moving counterclockwise, and you see here's our warm air mass. So there's step one. So this warm air mass is kind of chasing this cooler air, and then there is a cold front that's approaching from behind. So you can see how this warm air mass is going to get caught in the middle of this. Okay, so our next step of an occluded front, you can kind of see that it's starting to create the front right here. So now the cold air has kind of caught up to the warm air mass. You can see this warm air mass is stuck in between both of these cold air masses. So it's going to cause lots and lots of rain because we have this warm air that's rising on, both sides of this front. All right, and then you can see from the last picture here that it's just the occluded front takes on much more space as the rest of the cold front catches up with the warm front. And towards the tail end, you'll get some light rain.